Alright, so welcome back to my channel, Math and Language, and we're going to tackle hypothesis testing, C, value. So, itong topic na to, medyo mahaba to, but if you want to visit a specific topic, andun naman siya sa description box below. At yung problem solving mismo, nasa dulo siya ng video, but you may want to check the timestamp na lang, again, dun sa description box. So, let's start with the introduction. Ano nga ba ang hypothesis testing? Hypothesis testing is a decision-making process for evaluating claims about a population. Ito yung HO and HA na may kita nyo later. So, ito na. Chapter 2, HO and HA. So, yung H0, ipopronounce ko na lang HO. The null and alternate hypothesis. So, ang HO is the null hypothesis. It states that there is no difference between a parameter and a specific value. HA naman is the alternative hypothesis. It states a specific difference between a parameter and a specific value. Alright, so example number 1. The average age of doctors in Las Piñas is 35 years. So, ang HO natin dito will be, okay, yung mu, or yung parang letter U na yan, that is the symbol for average, or yung mean. So, HO, mean is equal to 35 years, at ang HA natin daw ay mean is not equal to 35 years. So, kumukontra yung alternative hypothesis. Another example. Example number 2, the average number of calories of a high-calorie meal is at least 600. So, ang HO natin dito, mean is equal to 600 calories. At ang HA natin is mean is greater than daw 600 calories. Okay, chapter 3 tayo. Two-tailed, left-tailed, at right-tailed. So, ano ba yung mga tailed na to? So, paano natin malalaman kung left, right, or two-tailed? So, first one, ang HO natin, parameter is equal to specific value, at ang HAS parameter is not equal to the specific value. So, pag equal and not equal, that will be two-tailed test. Next one, paano naman kung ang HO mo ay parameter is equal to specific value, or yung pangalawa is HA parameter is less than the specific value? So, that will be left-tailed test. Kapag ito ay less than, ito ay magiging left-tailed test. And lastly, parameter is equal to specific value for the HO, at ang HA natin, that will be parameter is greater than the specific value. That will be the right-tailed test. So, let's review. Pag not equal and not equal, two-tailed test yan. Kapag equal and less than, that will be left-tailed test. At kapag equal and greater than, that will be the right-tailed test. So, let's have some examples. So, in kanina, the average age of doctors in Las Piñas is 35 years. And we have HO, mean is 35 years, equal to 35 years. At ang HA natin, mean is not equal to 35 years. You have equal and not equal, so that will be a two-tailed test. Example number 2. The average number of calories of a high-calorie meal is at least 600. So, HO, mean is equal to 600 calories. At ang HA natin, that will be mean is greater than 600 calories. Remember, pag equal and greater than, that will be a right-tailed test. Example number 3. The average ELO rank or LO rank of an expert chess player is at least 1800. So, ang HO natin, ang mean is equal to 1800 ELO. At ang HA will be mean is less than 1800. So, dahil equal and less than, that will be a left-tailed test. So, malalaman natin mamaya bakit kailangan natin malaman kung two-tailed test, left-tailed, or right-tailed. Sa problem solving, madidiscover nyo bakit. So, let's go to the chapter 4, type 1 or type 2 error. So, ito naman kasi minsan nalabas talaga sa exam nyo to sa true or false to. So, we have the eject HO and do not reject HO dun sa column 2 and column 3. So, row 2 and row 3 naman, HO is true and HA is false. So, may nakalagay type 1 error, correct decision, and type 2 error. So, ganito lang siya kasimple. Type 1 error occurs if one rejects the null hypothesis when it is true. Yun lang yung tatandaan nyo. At pag type 2 error naman occurs if one does not reject the null hypothesis when it is false. So, remember this one kasi lalabas to sa true or false exam nyo. Most of the time, pag magpapa-exam ang prof nyo, lalabas to sa true or false. So, lalabas dito, pwedeng true or false, ang type 2 error ba occurs if one does not reject the null hypothesis when it is true? So, ang sagot dan ay false kasi dapat the null hypothesis when it is false. Okay, so level of significance. Chapter 5. Ano ba yung level of significance na yan? Ito yung maximum probability of committing a type 1 error. This probability is symbolized by alpha, the Greek letter alpha. Most of the significant levels are 0.10, 0.05, and 0.01 level. So, ito mostly nyo makikita na level of significance. Okay, so Chapter 6 tayo. Critical value. Ano ba yung critical value na yan? Critical value determines the critical level and the non-critical regions. The critical region naman, or rejection region, is the range of values of the test value that indicates that there is a significant difference and the null hypothesis should be rejected. At the non-critical region or non-rejection region is the range of values of the test value that indicates the difference was probably due to chance and the null hypothesis should not be rejected. So, malalaman natin yan mamaya. Mas maganda kung mayroon tayong illustration. Okay, critical value for two-tailed. Pag two-tailed nyo, ito yung magiging illustration. If the test is two-tailed, the critical value will be either positive or negative. So, kaliwat kanan yan. At remember, ang significant level nyo or level of significance, i-divide natin ng 2. So, for example, ang level of significance is 0.10 at kapag two-tailed test to, you have to divide it by 2. Isa sa kanan at isa sa kaliwa. So, makikita nyo dyan siya doon sa screen. At remember, negative C sa kaliwa at C sa kanan. Ito yung critical region, yung naka-green na shaded part. Alright, so paano naman pag critical value for left-tailed test? If the test is left-tailed, the critical value will be negative. At mapapansin mo, negative C tayo. And also, ang level of significance natin, hindi natin dinidivide ng 2. Unlike dun sa two-tailed test natin, dinidivide natin siya ng 2. Kasi dito, as is. Kung ano yung binigay na level of significance at left-tailed test, yun na yun. We do not need to divide it. So, mapapansin mo sa screen, alpha lang siya. Next one, we have the critical value for right-tailed test. If the test is right-tailed, the critical value will be positive. So, dito naman, yung critical region natin is sa kanan kasi nga right-tailed test tayo. And also, we're not going to divide it by 2. We're only going to divide the level of significance pag two-tailed test na siya. Alright, so let's move on to Chapter 7 using the Z table, finding the critical value given the significant value and the type of test. So let's have some examples. Sample number 1. Using the C table, find the critical value for level of significance is 0.01 and two-tailed test siya. Remember, if it's a two-tailed test, ang area for each tail will be divided by 2. Dun sa yung level of significance, divide natin ng 2. So that will be 0.005. So makikita nyo sa screen nyo, yung illustration, 0.005 sa kaliwa at 0.005 din sa kanan. At ito yung critical region natin. Saan ba nanggaling yung 0.495? Remember, yung buong area na yan sa ilalim ng curve is 1. Okay? So, sa gitna niyan, that will be 0.5. So, 0.495 yung sa kaliwang hindi shaded region at kanan din is 0.495. So, dapat mag-equal lahat yan sa 1. So, yung non-critical region mo, ito yung 0.495 dun sa kaliwa at sa kanan din. 0.495 each. Ngayon, gagamit tayo ng Z table to find the critical value for the level of significance ng 0.01. So, makikita natin ang 0.495 ay nasa gitna siya ng 0.949 and 0.49514, 2.57 and 2.58. So, gagawin natin dyan, i-add natin sila pareha, so divide natin ng 2. So, we will have an answer of plus minus 2.575. Bakit plus minus? Kasi two-tailed test yun eh. Next one. Using the C table, find the critical value for the level of significance 0.10, the left-tailed test. So, makikita nyo sa screen nyo, ang yung level of significance natin as 0.10 at left-tailed test siya. So, automatically, ang critical region mo nasa kaliwa siya. At, remember, ang buong curve na yan ay may area na 1, di ba? At yung kalahati is 0.5. So, dyan nanggaling yung 0.4. Kasi pag in-add mo yung 0.10 at 0.4, that will be 0.5. Hanapin na natin ano ba yung level of significance na yan, yung sa C table. So, we have 0.4. Hanapin natin dapat yung 0.4. So, ang pinakamalapit na value is yung 0.3997. So, we're going to take the C value as 1.2 plus 1 ng 0.08. That will be 1.28. At dahil left-tailed test to, that will be a negative value. Remember, yung C value na kinukuha ko, ito yung layo niya doon sa sentro. Kaya, napapansin mo, 1.28 yung sagot. But this one is negative kasi left-tailed test tayo. Okay, so chapter 8 tayo, we have the Z-test formula. The Z-test is a statistical test for the mean of a population, can be used when the sample size is greater than 30 or when the population is normally distributed and the Z is equal to the quantity sample mean minus mo siya sa hypothesized mean. Yung sagot na yan, o-over natin sa fraction na population deviation, over mo siya sa square root ng sample size. So let's have some example. Example number 1. A manufacturer claims that the average lifetime of his light bulbs is 36 months. The standard deviation is 8 months. 50 bulbs are selected and the average lifetime is found to be 32 months. Should the manufacturer's statement be rejected at level of significance is equal to 0.01? So first step, lagyan natin yung formula. Second step is we substitute it. So ang sample mean natin, that will be 32. At ang hypothesized mean, that will be 36. So, color-coded naman tayo. At ang population deviation natin, that will be 8. At yung nasa loob ng square root, that will be 50. Simplifying it, we will have an answer of negative 3.54. Alright, so next one, Z-test formula, example number 2. A test on car-braking reaction times for women between 18 to 45 years old have produced a mean and a standard deviation of 0.610 seconds and 0.123 seconds respectively. When 40 female drivers of this age group were randomly selected and tested for their braking reaction times, a mean of 0.587 seconds came out. At the level of significance 0.10, test the claim of the driving instructor that his graduates had faster reaction times. Okay, mukhang komplikado siya, but we just need the values. So, lagay mo agad yung formula. Next step, lagyan natin yung mga values. Ang sample mean natin, that will be 0.587. At ang hypothesized mean, that will be 0.610. So, ganito lang yan. Ang hypothesized mean, ito yung original. At yung sample mean, yung 0.587, ito yung dinedebate nila. Or yung parang gusto nilang ilaban na hindi to 0.610 seconds. Dapat ito ay 0.587 seconds. Over tayo dun sa fraction na 0.123. Ito yung standard deviation natin. At yung sa loob ng square root, that will be 40. Kasi ito yung sample size. Simplifying it, you will get an answer of negative 1.18. So, ganun lang kadali para makuha yung formula na to. So, next na tayo, dinunta tayo sa problem solving. So, ito na yung real deal at dito natin gagamitin lahat na natutunan natin from the previous lessons. So, we have steps in answering alternate hypothesis. The first one is state the null and alternate hypothesis. Second one is select the level of significance. Third one is determine the critical value and the rejection region. Fourth one is state the decision rule. And number 5 is compute the test statistic. And number 6, make a decision whether to reject or not to reject the null hypothesis or the conclusion. Okay, problem solving number 1. A manufacturer claims that the average lifetime of his light bulbs is 36 months. The standard deviation is 8 months. 50 bulbs are selected and the average lifetime is found to be 32 months. Should the manufacturer's statement be rejected at alpha is equal to 0.01 or level of significance? Step 1. State the null and alternate hypothesis. So we have HO, mean is equal to 36 months. HA, ang mean daw, is not equal to 36 months. So, ang original is 36 months daw, yung average lifetime ng light bulb. Kaso may gustong magsabi na hindi talaga siya equal sa 36 months. So, ang HA natin is mean is not equal to 36 months. Alright, so step 2 is select the level of significance. So, given naman siya. So, that will be 0.01. Step 3 natin, determine the critical value and the rejection region. Remember, this is a two-tailed test kasi equal and not equal. So, ang level of significance natin, i-divide natin siya ng 2. So, from 0.01, magiging 0.005 siya. At makikita nyo sa illustration, so kaliwat kanan yung critical region natin. Yung naka-shaded part na green. Okay? So, 0.005 sa kaliwa at 0.005 din sa kanan. Kaso, hanapin natin yung C-value doon sa value ng layo from the center dun sa critical region. So, that will be 0.495. Okay? 0.005 dun sa critical region. But remember, hanapin natin yung layo nila from the center to the critical region. So, 0.495. So, pag i-check mo siya sa C-table natin, nakikita nyo, nasa kalagitnaan siya ng 0.4949 and 0.4951. So, ang gagawin mo, we have 2.57 plus 2.58. Kung yung average nila, so that will be 2.575. Ito na yung C-value natin. Right, step 4 is state the decision rule. We can only reject the null hypothesis kapag yung computed C-value natin is greater than 2.575 or less than 2.5 negative or less than negative 2.575 siya. Okay, so step 5 natin is compute the test statistic. Ito na yung malalaman natin kung yung computed C-value. So we have 32 minus 36, over mo siya dun sa 8 over square root of 50. Simplify that, that will be negative 3.54. At dahil mas less siya sa negative 2.575, mas maliit siya dun sa negative 2.575, reject natin yung HO. So, ito yung step 6. Make a decision whether to reject or not to reject the null hypothesis. Remember, ang negative 3.54 ay nag-fall sa critical region. So, the test statistic, the computed C-value is equal to negative 3.54 is less than the critical value dun sa tabular value na C-value, which is negative 2.575. And it falls in the rejection region and in the left tail. Therefore, reject the HO and conclude that the average lifetime of the light bulbs is not equal to 36 months. So, yung claim ng manufacturer na yung average lifetime daw ng light bulbs na ay 36 months ay na-reject na natin. Alright, so next one, problem solving number 2. A test on the car braking reaction times for men between 20 to 30 years old have produced a mean and standard deviation of 0.610 seconds and 0.123 seconds, respectively. When 40 male drivers of this age group were randomly selected and tested for their braking reaction times, a mean of 0.587 seconds came out. At the level of significance of 0.10, tested the claim of the driving instructor that his graduates had faster reaction times. So, first step tayo, state the null and alternate hypothesis. So, yung original is mean is equal to 0.610 seconds. Ito daw yung braking reaction times ng men between 20 to 30 years old. Kaso, ang HA daw natin, or alternative hypothesis, is less than 0.610 seconds. Okay, step 2, select the level of significance. It is given naman, so that will be 0.10. Step 3, determine the critical value and the rejection region. So, left-tailed siya kasi ito ay equal and less than. At hindi natin i-divide ng 2 ang level of significance kasi ito ay isang left-tailed lang. Okay, so dahil left-tailed to, hanapin na natin yung C-value. So, we have 0.10 ito sa critical region at yung layo niya dun sa center, so may 0.10 na tayo, so 0.5 minus 0.10, that will be 0.4. So, doon ko nakuha yung layo from center to the critical region, that is 0.4. Okay? So, yun yung gagamitin natin para mahanap yung C-value. And ang pinakamalapit daw sa table ay nasa 0.3997. So, that will be 1.2 plus mo ng 0.08. So, the C-value will be negative 1.28. Ito yung tabular C-value natin. Okay, so ito yung critical value. Negative tayo kasi left-tailed. Step 4, state the decision rule. Mag-reject tayo ng null hypothesis kapag daw yung computed C-value ay less than negative 1.28. So, mapapansin nyo sa illustration, yung reject HO pag less than siya sa negative 1.28. At kapag greater naman siya, do not reject the null hypothesis. Step 5, compute the test statistic or yung computed C-value. So, Z is equal to 0.587 minus mo ng 0.610. At sa baba naman yan, another fraction. So, 0.123 over the square root of 40. And simplify that will be negative 1.18. At mapapansin mo, ang negative 1.18 is greater than negative 1.28. Since the test statistics falls within the non-critical region, do not reject the null hypothesis. There is not enough evidence to support the instructor's claim. Ito yung step 6. Make a decision whether to reject or not to reject the null hypothesis. So, makikita nyo naman, ganito lang yan. Yung computed C-value mo ay negative 1.18. So, mapansin mo, lahat ng negative 1.28 pababa, ito yung i-reject natin. At dahil ang negative 1.18 ay mas mataas sa negative 1.28, hindi natin i-reject yung null hypothesis. And that's the end of the lesson about hypothesis testing C-value. You would like to comment or suggest another math and language video or kung may assignment kayo, please comment down below. Again, this is James, your math and language instructor. Please also like, subscribe, at click also the bell notification para updated kayo sa bagong math and language video. Thank you. Bye-bye.